All right, we're recording. All right, so for our review, section 9 review, y'all ready? Y'all ready? Number 1 and 2, those are exponential functions, which we know exponential functions have horizontal asymptotes, right? We know it's exponential because there's a variable in the exponent. So I'll do number 1 with you. What would be the y-intercept for number 1? The 2. Remember, whatever your a is the y-intercept. So we know this graph's going to cross the x-axis at 2. Might need to get my old lady glasses out for this. It's tiny. Oh, I can see so much better. Hold on. And is number 1 going to be a growth or a decay? A growth. So just knowing those two things, you could probably eliminate, if it was multiple choice. It might not be multiple choice on the graph. But if it was, you could eliminate some stuff. All right, so we said it's going to be a growth because b is greater than 1. Remember, it's between 0 and 1, like on number 2. That would be a decay. That's when as your x values increase, your y values decrease. All right, so we know our y-intercept's going to be. We know from left to right the y values are going to increase. So just pick a couple of values to put on your graph and figure out what your graph's going to look like. So if I do, let's see, I'll go with -4. So y equals 2 times 3 raised to the -4. Well, even if you just put that in your calculator and get a decimal, I'm fine with that. 3 raised to the 4 negative is 0.01. Multiply that by 2, and I get 0.02. So when x is -4, y is 0.02. All right, let me do -1. So y equals 2 times 3 raised to the -1. Do not do 2 times 3 first. You're going to get the wrong answer. Have to do exponents before multiplication. So 3 raised to the -1 is 0.3 repeating. Oh, times 2? No. 0.6 repeating. Thank you. Move it up a little bit. And let me just pick some number greater than 0. I'll do +2. So y equals 2 times 3 squared. 3 squared is 9. 2 times 9 is 18. So when x is 2, y is 18. Julio? And you know on number 2, what's your y-intercept going to be? 4, and it's going to be a decay. So just knowing that little information, you have a little bit to go on, right? So just find some other ordered pairs to help fill in the gaps. So you have a little bit more accuracy. Everybody cool with that? Now 3 and 4 are logarithms. Remember, logarithms have a vertical asymptote, not horizontal. So on number 3, where's your asymptote going to be?
1.
At +1, right? It's whatever your h is, but you got to change the sign. So I would draw in my asymptote first. And when you have a logarithm, it's always to the right of the asymptote unless it's a reflection. And to know if it's a reflection, this logarithm would be multiplied by a negative number. Okay? So if it's not, then it's going to be on the right side. If it's a reflection, it would be on the left side. So even just knowing that, you could probably eliminate some choices if it was multiple choice.
Ms. Rayleigh,
Yes?
is Amaria Sanders in class?
Yes?
Will you please send her to discipline?
Sure?
Thank you.
You're welcome. You have your phone you can scan out? Okay. And make sure you take this pass with you too. Alright, so what I want to pick x values that were 1 or less than 1 for this example. No, because if I did, I'm just going to get an error message because my graph's not going to have an x value that's 1 or less than that. So I would start with maybe 2. So we have y equals log base 3 of x will be 2. 2 minus 1 minus 1. So that's log base 3 of 2 minus 1 is 1 minus 1. Do not do the 1 minus 1 first. I evaluate log base 3 of 1 first. How are we going to evaluate log base 3 of 1? Yes, which is called what? The change of base. You have to do 1 log divided by 3 log. If you do that backwards, it won't work. So 1 log divided by 3 log equals 0. So when x is 2, y is 0. So that's my x-intercept. Let me do 6 when x is 6. So that would be y equals log base 3 of 6 minus 1 minus 1, which is log base 3 of 5 minus 1. Leah. Yeah. Oh, did I not? Oh, these things are killing me. I'm recording video. And I already messed up. Did I not? Okay, let me go back. Alright, I might have to make a new video. Alright, so 1 log divided by 3 log equals 0. And 0, no I didn't. And 0 minus 1 would be negative 1. Thank you. So when x is 2, y is negative 1. Too much going on, trying to concentrate. Log of 1 divided by log of 3. Alright, let me try this again. So in this one would be log of 5 divided by 5 log divided by 3 log. 5 log divided by 3 log. And don't forget to put your equal sign. And, like I did on last time, don't forget to subtract 1. So I get approximately so when x is 6, that's just barely over the x-axis. Is that going to be a straight line? No, it's a logarithm, right? Well, let me just try 8. I'm running out of room. So I can probably do this in my head. 8 minus 1 is 7. So I'll do 7 log divided by 3 log. 7 log divided by 3 log equals, and then subtract 1. So when it's 8, it's at 0.77. So I know from this point it's curving upwards. Now, is that what my graph's going to look like? Just that? No, remember it's going to come down and hug the asymptote. If I want to know exact values for that, I could pick numbers between 1 and 2. 1.1, 1.2, 1.3, 1.4, whatever. Any value between 1 and 2. If I get confused by that. But I know if that asymptote's there, my graph's not going to cross it. On your homework, a lot of your graphs cross the asymptote. They don't do that. It's asymptotes. It just hugs it. Okay? So I know I made some mistakes on there. I'm probably confused y'all, but does anybody have any questions? Okay. Hopefully I don't have to wear my old lady glasses after that. Graphs. Alright, 5 through 8 solve each equation. So if you look at all of these, they're exponential equations, and all of them can be written with the same base. So you could either solve them that way, or you could write them as logarithms. Okay? So on number 5, if I wrote them both with the same base, 625. Does anybody know 5 raised to the what gives me 625? If we didn't know, we could just use our calculator, right? We know 5 cubes, 125. What'd you think it was? Oh, 5 to the 4th. So I could rewrite 625 as 5 raised to the 4th power. And on the left side, 5 raised to the k plus 3. So remember, it's been a while since we've done this. If our bases are equal, then our exponents must be equal, right? So once we have our bases set equal to each other, don't worry about them anymore. Just take your exponents and set them equal to each other. and solve for the variable. So I would just subtract 3, and k equals 1. And just double check that. If I substituted 1 in for k, that would be 1 plus 3 is 4. 5 to the 4th equals 625. Is that true? Yes. Number 6, the bases are already equal. So all you have to do is set those exponents equal to each other. And solve for the variable. So I would add x to both sides. Of course, you don't have to do that first. There's other things you could do. And get 3 equals 4x minus 1. Add 1 to both sides. 4 equals 4x. Divide both sides by 4, or divide each term, and x equals 1. Coolio? This test's going to be easy, isn't it? All right, 9 and 10. Evaluate each expression. How am I going to evaluate those logarithms?
4 raised to the x equals 64.
I could do that. Yeah, we could just do change of base as well, right? But you could do what you were saying as well. So, because my base is a number, not a variable, and what I'm taking the logarithm of is a number, no variables. So when that's the case, remember, we could just use our calculator, change of base. You just have to make sure you enter it correctly. So, like on this one, would be 64 log divided by 4 log. Can somebody please get that? So 64 log divided by 4 log, and don't forget to press your equal sign. Having a test next class. Thank you, sit over there. Coolio? Memorize the order in which you have to enter into your calculator. If you put it in backwards, I guarantee you that 4 log divided by 64 log, I bet there will be an answer on your test of 0.3 repeating. You know what I mean? So, you don't want that one. You don't want that one. All right, backside 11 and 12 is also change of base. 13 through 18, solve each equation, round your answer to the nearest thousandths. Okay, so you can see in those that the variables are in the exponent. So those are exponential equations. So I can tell in number 13, that's not an exponential form yet, though. So get an exponential form first, then determine, do I need to rewrite this as a logarithm, or can I write both sides with the same base and go from there? So on 13, what would we need to do to get it in exponential form? Add 3. So 14 raised to the b minus 3 equals 24.7. Are we going to be able to write both sides with the same base? Same base? No. So we will convert it to a logarithm. Got to make sure you convert it correctly. So that would be log base what? 14 of 24.7 equals b minus 3. Now what would we do? Change a base. So 24.7 log divided by 14 log. Don't forget to push your equal sign. It's 1.215. And then what are we going to do from there? Because I'm kind of out of room. So add 3. And we get approximately, what does it say? Round to the nearest 10 thousandths. Tenths, hundredths, thousandths, 10 thousandths. So 4.2151 approximately. So look at number 18. What would I need to do to get that in exponential form? Are you sure? Yeah, that's why I picked that one. Because a lot of people want to add 5 because it says minus 5, right? But that negative 5 is being multiplied by 13 raised to the 5.8n. So don't make that mistake. divide both sides by negative 5 each term. So I have 13. Does that say 5.8 in? Yeah. Equals positive 5. Can we write both sides with the same base? What do? Write it as a logarithm. So that would be log base
13?
of 5 equals 5 and 8/10 in. Remember, a lot of kids keep thinking this is 13 raised to the 5th power. That's not what it is. It's a logarithm. So now we can do change of base, right? 5 log divided by 13 log equals 0.0537. And I didn't round that right. I'm looking at that, but that's okay because I'm going to leave the actual number, not the rounded number, in my calculator, and I can round at the end correctly. So I'm dividing by 5 and 8/10. So now I need to round correctly. Tenths, hundredths, thousandths, 10,000ths. Is that 2 going to stay a 2 or go up to a 3? So 0.0093 approximately. Everybody cool with that? And each of those problems on there, they're all just like the 2 I just did. And if you need more help with these, I've put a video, I believe, for every lesson. You got to go to Teams, but there's a video for each lesson. If you don't remember something, go back to Teams. Download Teams on your phone. Probably want to download OneNote as well. Okay, 19 through 22. Write each equation in exponential form. I mean, seriously, we're going to get points for this? I mean, on 19, what would that be in exponential form? Remember the Snell method. Just convert it back to exponential.
Which one?
19. Exactly. 9 squared equals 81. Remember, start with a base and make your little Snell. 9 squared equals 81. That's all you have to do. It's in logarithmic form. You're converting it to exponential form. That's it. Easy enough, right? Okay. 23 through 30. Rewrite in logarithmic form. Okay, more easy problems. So right now, they are in exponential form. You just have to rewrite them in logarithmic form.
On your number 18 wrong. We're not getting that answer.
Oh, yeah? Okay, let me look at it.
I got 0.1082.
All right, let me go back and look. Divided everything by negative 5. So that's 13 raised to the 5.8 n equals positive 5, right? So log base 13 of 5 equals 5 and 8/10. All right, let's see if I did this in the calculator right. 5 log divided by 13 log. Oh, wonder if I did it for 5 log divided by 13 log equals. You're right. I wonder if I did the same thing I just did, almost did then. I did 13 equals and didn't push log. So, why I gotta mess up? I'm making a video. So that number, 0.6274, divide that by 5.8. Is that what you got?
Yeah.
Okay. 0.1082. Good thing only like 13 people follow me on YouTube. I just only do this for y'all. And everyone's here today, so you probably won't be going back and rewatching the video. All right, thank you for pointing that out. All right, so 23 through 30, I'm just writing in logarithmic form, the opposite of what we just did on 19 through 22. So 23, it's in exponential form. Logarithmic form would be log base what? 8 of 164 equals -2. And is it okay, what's in this spot over here, what we usually call the y, is it okay if that's negative? Yes, but your base can't be negative, and what you're taking the logarithm of can't be negative. But what it's set equal to, that can be negative. All right, that's all you're doing. There's no solving. There's no variables to solve for anyway. In that one, you're just rewriting it logarithmic form. That's all you have to do. So just remember, whatever it is that has the exponent, that's what your base is. That number that's on the other side by itself, that's what you're taking the logarithm of. The exponent goes on the other side. Everybody cool with that? Okay. 31. Say you deposited $20,000 in an account that earns 7.5% interest that is compounded continuously. How long would it take to earn $100,000? I'm not going to do this example for you, but I'm not going to give you the formula either. Do y'all remember the formula? It's compounded continuously, so it's that one that has the E in it.
It's like
P
P
of T times E
and then RT.
to the RT.
Yeah, so it's A of T. Remember, that's the amount in the account after 2 years equals, yes, P times E raised to the RT. I'm not going to give you that on the test. Do we know the amount in the account after 2 years?
No.
Yes.
Oh, yeah.
How long would it take to earn $100,000? What does P stand for?
Your initial.
Which is
20,000.
20,000. Is E a variable?
No, that's your.
Euler's number.
Euler's number, right, or Euler's number. So we just put that in the calculator, E, or 2.71828. And what's our rate in this one?
It has to be decimal.
0.075.
Very good. And do we know the time? So time's what we're looking for, right? So that means we're going to have a variable in the exponent. So this will end up being an exponential equation that you have to solve. Okay? This one will not be multiple choice on your test. The graphs might not be multiple choice on your test. Don't know. They may not all be multiple choice. Most of them will be. Any questions? Okay. So y'all spend the rest of the class finishing the review. I will write the answers out so that you see them. And we'll have them because we're taking our tests on Monday, which is a C day. And we want to come in and get started right away. So we have as much time as possible, okay?
So what are we doing next?
And everyone will be on time Monday.
What are we doing next?